Something extraordinary has just emerged from the data. The results were impossible to ignore. The path changed, not slightly, not gradually, but decisively.
We've been tracking 3I Atlas from the very beginning, but this latest update changes everything. Avi Loeb now says its unusual path has only a 0.2% chance of being natural, and that claim is forcing scientists to stop and rethink what they are seeing. New data is coming in, theories are breaking down, and something about this object feels deeply off. What we're about to reveal is bigger than expected. Dr. Avi Loeb's another shocking revelation. Dr. Avi Loeb, a professor of astronomy at Harvard University, has been studying 3I Atlas intensely, and his new findings have shocked the scientific world. According to his recent calculations, the path that 3I Atlas is taking through our solar system is extremely unusual. The object is moving in a retrograde orbit, meaning it is traveling in the opposite direction of most planets and objects in our system. But that is not the strange part. The strange part is how perfectly it is aligned with everything else. Loeb calculated that the trajectory of 3I Atlas is aligned almost exactly with the plane of our planets. Think of the solar system like a flat disk with the sun in the middle, and all the planets orbiting on roughly the same level. An object coming from interstellar space could arrive from any direction at all, up, down, sideways, at any angle. But 3I Atlas came in almost perfectly flat with everything else. The chance of this happening naturally, according to his math, is only 0.2%. That is 1 in 500. Think about that for a moment. An object travels across interstellar space for millions of years, enters our solar system, and just happens to line up almost perfectly with the planetary plane. Either we got incredibly lucky, or something else is going on here. This rare alignment was just the beginning. As scientists continued watching 3I Atlas, more strange behaviors started to emerge, behaviors that do not fit any known model of how comets or asteroids should act. The mystery was only getting deeper, doing things comets should not do. Here is what we know about normal comets. When they get close to the sun, the heat causes ice on their surface to turn into gas. This creates a tail that always points away from the sun, pushed by solar wind and radiation. It is a beautiful and predictable process that we have observed countless times over centuries of astronomy. 3I Atlas did not get that memo. It decided to do its own thing. Observers noticed something called an anti-tail forming on this object. Instead of pointing away from the sun like it should, material was streaming straight toward the sun. This is highly unusual and goes against the basic physics we expect from cometary activity. It is like watching water flow uphill. It should not happen, but there it was. But it gets weirder, much weirder. The object also displayed what scientists call non-gravitational acceleration. In simple terms, its path could not be explained by gravity alone. Something else was pushing or pulling it. Usually, when we see this in comets, it is because gas and dust are shooting out from the surface, acting like tiny rocket thrusters. The force of material escaping can nudge the comet in unexpected directions. But the patterns in 3I Atlas were different. They were irregular, they were powerful, and they were changing direction in ways that did not match the heating and cooling cycles you would expect as the object moved around the sun. The jets seemed to have a mind of their own. Scientists ran model after model, trying to explain these movements using conventional physics. Every time, the results left gaps. Something was not adding up. The equations were not balancing. The predictions were not matching reality. And just when researchers thought they had seen all the strange behavior this object had to offer, they started noticing something in the light it was emitting. Something that would make the mystery even deeper and more puzzling. The heartbeat in the dark. Every object in space reflects or emits light that we can study. Scientists look at what is called a light curve, which shows how an object's brightness changes over time. For most asteroids and comets, this brightness goes up and down somewhat randomly as they rotate and as their distance from the sun changes. It is chaotic and unpredictable. 3i Atlas showed something very different, something nobody expected. Researchers detected a periodic pulse in its brightness that repeated every 16.16 hours, like clockwork, regular, steady, precise. Some scientists have described it as heartbeat-like, unlike the random flickering you might expect from a tumbling chunk of rock and ice. This object was pulsing with a rhythm that seemed almost deliberate. Dr. Loeb pointed out that this consistent pulse is not characteristic of any natural object known to science. When ice and gas sublimate from a comet's surface, they tend to produce irregular, variable outputs. The heating is uneven. The rotation affects things differently depending on which side faces the sun. You get chaos, not rhythm. You get randomness, not precision. But 3i Atlas was pulsing with remarkable precision, every 16.16 hours, like a cosmic heartbeat. Astronomers also noticed something even more intriguing. The pulse seemed to correlate with other anomalies they were observing. Changes in jet intensity and direction appeared to coincide with moments of maximum brightness. It was as if the object's internal activity was somehow connected to its light output. Everything seemed linked together in ways that made no natural sense. Mainstream scientists urged caution. They emphasized that we have only observed 3 interstellar objects ever. Unusual behaviors might just be what happens when you observe something this rare. Maybe rotation effects or uneven material distribution could create these patterns naturally. Maybe we just need to study more objects before jumping to conclusions. But even with those explanations, the heartbeat stood out. It reinforced the idea that this object was behaving unlike anything we had ever seen before. It made people start asking questions they usually avoided. What is this thing made of? Scientists pointed their most powerful instruments at 3i Atlas, hoping to figure out what it was made of. Using spectroscopy, they analyzed the light coming from the object's coma, the cloud of gas and dust surrounding it. By studying how light interacts with different materials, they can determine what chemicals and elements are present. The results surprised everyone. Some results even shocked the experts. Methanol levels were much higher than expected compared to typical comets. Methanol is not unusual in comets, but the relative abundance here was striking. It suggested that 3i Atlas formed under very different conditions than most objects we have studied, or that it had experienced processes during its long journey through interstellar space that changed its chemistry in unexpected ways. Then came the metals. This is where things got really interesting. Some analyses detected traces of metallic elements, including nickel. Now, metals exist in small quantities in most comets, mixed in with the dust. But the patterns observed in 3i Atlas were unusual. The metal signatures were stronger and distributed differently than in normal cometary objects. Some researchers, including Loeb, suggested that such compositions could hint at formation mechanisms beyond natural icy bodies. Could this object have been manufactured? Others were more cautious, pointing out that interstellar chemistry can produce unexpected results, especially in objects that have traveled through varied environments in space for millions of years. Perhaps the object passed through regions of space we do not understand, picking up unusual materials along the way. A crucial test came in late October 2025 when 3i Atlas reached perihelion, its closest approach to the Sun. This is when comets usually show their most intense activity. The heat triggers massive sublimation, and if an object is fragile, this is when it might break apart under the stress. 3i Atlas showed strong jets and anti-tail formations during this period, but remarkably, it stayed intact. If massive natural outgassing were occurring, an object of this size and composition might be expected to fragment or lose significant mass. But it survived, defying expectations once again. It held together when it should have fallen apart. The question no one wants to ask. Now we arrive at the most controversial part of this story, the part that makes some scientists uncomfortable and others excited. Dr. Avi Loeb has spent years thinking about interstellar objects and what they might mean for our understanding of the universe. He was one of the first scientists to suggest that Oumuamua, the first interstellar visitor, might not be entirely natural. That idea was heavily criticized at the time. Many scientists dismissed it as speculative and unscientific. With 3I Atlas, Loeb has gone further, much further. He has suggested that this object might be a technological artifact, a probe, something sent by an advanced extraterrestrial civilization, similar to how humanity launched the Voyager spacecraft. Decades ago, we sent Voyager out to explore the cosmos and eventually leave our solar system. Why could another civilization not do the same thing? Loeb points to the rare trajectory, the non-gravitational acceleration, the heartbeat like pulsing, the unusual jets, and the unexpected chemical composition. Any single anomaly might have a natural explanation, but together, they form a pattern that becomes extremely unlikely under standard physics. How many coincidences are too many? Loeb and his colleagues have even developed a framework for assessing how likely an interstellar object might be artificial. By this measure, 3I Atlas scores unusually high, far beyond previous visitors. The scale does not claim certainty, but it quantifies just how strange this object is compared to what we would expect from nature alone. Critics, including many prominent astronomers, push back hard on this idea. They argue that extraordinary claims require extraordinary proof. With only 3 interstellar objects ever observed, unusual behavior might just be rare, not artificial. They emphasize that jumping to conclusions about alien technology is premature and could damage scientific credibility for years to come. But here is the thing. Even the skeptics admit that 3I Atlas is strange. Even they cannot fully explain all of its behaviors using conventional models. The debate is not about whether the object is unusual. Everyone agrees on that. The debate is about what unusual actually means. Getting close to Earth. Before you start worrying, let us reassure you. NASA has made it very clear that 3I Atlas poses absolutely no threat to Earth. None at all. The object will come closest to our planet on December 19th, 2025. But even then, it will be about 170 million miles away. That is a safe distance in cosmic terms, far beyond the orbit of Mars. But that close approach does give scientists a rare and valuable opportunity. Observatories on Earth and in space are preparing to gather as much data as possible during this window. They will study its coma, its nucleus, its dust trails. Every detail will be scrutinized to see if it matches known comet behavior or if it hints at something more complex. This is their best chance to understand what this thing really is. The object has already passed some significant milestones. It flew by Mars on October 3rd, 2025, and reached its closest point to the Sun around October 29th, 2025. Throughout these passes, it continued to behave strangely, maintaining its unusual jets and anti-tails, pulsing with that steady rhythm and defying easy explanation at every turn. What happens next could be even more interesting and more revealing: the Jupiter encounter. After leaving the inner solar system, 3I Atlas is heading toward Jupiter. On March 16th, 2026, it will make an extremely close pass by the giant planet, coming within about 54 million kilometers of Jupiter's center. This is right near what scientists call Jupiter's Hill radius, the boundary where the planet's gravitational influence dominates over the Sun. Why does this matter so much? Let us explain. Jupiter's enormous gravity can significantly alter the paths of passing objects. Many comets and asteroids experience a gravitational slingshot when they swing by the gas giant, gaining speed or being redirected onto new trajectories. Simulations show that Jupiter's influence will affect 3I Atlas more than any previous planetary pass, bending its path as it prepares to leave our solar system forever. But here is where Loeb gets really interesting and controversial. He has pointed out that the near-perfect match between 3I Atlas's closest approach and Jupiter's Hill radius is extremely unlikely to occur naturally. He estimates the probability at roughly 1 in 26,000. Not impossible, but remarkably improbable. Loeb suggests that if the object were artificial or semi-controlled, this alignment could be deliberate. accurate. Think about it for a moment. If you were an advanced civilization sending a probe to study a solar system, where would you want it to go? Jupiter offers a stable vantage point for surveying the entire solar system while requiring minimal energy for course adjustments. It is exactly where you might position something if you wanted to observe for a long time. It would be the perfect parking spot. Mainstream astronomers counter that gravitational interactions with Jupiter are a natural consequence for any object passing through the outer solar system. The match with the Hill radius might just be coincidence, nothing more, but they will be watching closely all the same. Everyone wants to know what happens next. Let us step back and look at everything we have learned about this mysterious visitor. We have an interstellar object with a trajectory that has only a 0.2% chance of being natural. It has anti-tails and jets pointing in unexpected directions. It displays non-gravitational acceleration that cannot be fully explained by standard physics. Its brightness pulses with clockwork regularity every 16.16 hours. It has unusual chemical compositions, including elevated methanol and metallic traces. It survived perihelion intact despite intense solar heating, and it is on course to pass remarkably close to Jupiter's Hill radius. Each of these anomalies, taken alone, might have a natural explanation, but together, the probability of all these unusual features occurring in the same object by chance becomes vanishingly small. It strains credibility to call it all coincidence. This is the heart of the debate. How many coincidences can we accept before we start considering alternative explanations? At what point does coincidence become too convenient? Dr. Loeb is not claiming with certainty that 3I Atlas is an alien probe. He is saying that we should investigate with all possibilities in mind. He is arguing that science should not dismiss unusual ideas just because they are unusual. The history of scientific discovery is full of ideas that seemed crazy at first, but turned out to be true. His critics are not saying he is wrong to ask questions. They are saying that extraordinary claims require extraordinary evidence, and we do not have that evidence yet. Both sides agree on one thing. We need more data. We need more observations. We need more time. Preparing for the future. Regardless of whether 3I Atlas turns out to be natural or artificial, this object has taught us something important. We are not prepared for interstellar visitors. Not even close. In just a few years, we have detected 3 objects from other star systems passing through our cosmic neighborhood. Each one has raised questions we could not fully answer. Each one has slipped away before we could study it properly. We are always playing catch-up. Loeb and others are calling for better preparation. They want improved detection systems that can spot these objects earlier while they are still far away. They want spacecraft ready to launch on short notice to intercept and study interstellar visitors up close. They want frameworks for analyzing anomalies and deciding when unusual behavior warrants closer investigation. The next interstellar object could arrive next year, or next decade, or tomorrow. When it comes, will we be ready? Will we have the tools and the mindset to study it properly? Or will we watch helplessly as another mystery slips through our fingers and disappears into the darkness? 3I Atlas will continue its journey regardless of what we think or believe. After passing Jupiter in 2026, it will head outward on its hyperbolic escape trajectory, leaving our solar system behind forever. It will eventually return to interstellar space, heading toward the constellation Gemini, where it likely originated millions of years ago. We have a small window to study it, a few months of observations before it becomes too distant and faint to track. Every telescope that can point at it is working overtime. Every piece of data is being analyzed, debated, and published. Scientists around the world are racing against time. What will we find? Nobody knows for certain, maybe the upcoming observations will reveal a perfectly natural explanation for all the anomalies. Maybe scientists will identify a new type of comet that forms in interstellar space with unusual properties we have never seen before. Maybe everything will make sense, and we will file 3I Atlas away as just another weird but natural phenomenon. Or maybe not. Maybe this is different. Maybe the more we study this object, the stranger it will become. Maybe the upcoming Jupiter encounter will reveal something unexpected that changes everything. Maybe decades from now, scientists will look back at 3I Atlas as the moment when everything changed for humanity. We are living through a remarkable time in human history. For the first time ever, we are observing objects that come from other stars. We are seeing the universe deliver packages to our doorstep, visitors from distant suns carrying secrets we are only beginning to understand. 3I Atlas is asking us a profound question. Are we alone in this vast universe? Is this cosmos just rocks and ice and random physics? Or is there something else out there, something that sends probes across the vast emptiness between stars, exploring solar systems just like we explore our own neighborhood? We do not have the answer yet. But for the first time in human history, we are finally taking the question seriously. And that might be the most important thing of all. What do you think about 3I Atlas and its strange journey through our solar system? Share your thoughts in the comments below.